the sample is, remember, sampling distribution is the standard deviation of the population divided by the square root of the sample size, and is always the sample size. So you could do that on your calculator, but in Excel, it would be the standard deviation of the population, which is 6, divided by square root, SQ. You always have to hit equal when you're doing the calculation, QRT. And then this pops up here, square root of what? Sample size, which is, oh, I forget what the sample size is. How many? 33. Oh, it's right here, 33, okay? And then you have to close the parentheses, okay? So 1.04466, whatever, okay? All right? 45, okay, if you round it to the places they did, okay? All right? So now that's the standard deviation of the sample distribution, okay? So now the next question is, what is the probability that I randomly select one person and it's between 16.6 and 17.1 ounces a day, okay? Well, one person, the standard deviation, we used a population standard deviation because what's the square root of 1, okay? Sample size is 1, n is 1. What's the square root of 1? 1. What's the population standard deviation? Divided by 1, population standard deviation. So for one sample, we do the same thing we did last chapter, except, you do exactly the same thing we did for last chapter. For the probability of less than, so to get the probability between 16.6 and 17.1, we do less than 16.6, probability less than 17.1, and we subtract the 1 from the other, just like we did last chapter. And how did we do that last chapter? We used formulas, more function statistical, norm.dist. Make sure you use norm.dist, not this one, not norm.s.dist, norm.dist, there's a big difference, okay? And your x, which is 16.6, the mean is 17, standard deviation, we're doing 6 this time, and the cumulative is always 1, okay? So the probability less than 16.6 is 0.47, etc., okay? Now we do the same thing for 17.1. So far we're not doing anything different than we did last chapter. Hopefully it wasn't that long ago you remember. Okay, norm.dist, all right? And x value is 17.1. The mean is 17, standard deviation is 6, cumulative always 1, okay? There's that. So now the difference is the answer. You could go ahead on your calculator and do this minus this, but I'm gonna do it in Excel. I'm going to hit equals this number minus this number, and there's my answer, 0.0332. When you round it to 4 decimal places, 0.0332, okay? All right, now we're going to do the same exact thing, no different for this one, except since we're using 33 people, we're going to use the standard deviation that we calculated up here, use that standard deviation, okay? And again, in Excel, and this is why I calculated in Excel, because I'm just going to grab that, okay? For 33 samples, norm.dist again, norm.dist, x is 16.6, mean is 17. Now, the standard deviation, I'm going to put my cursor in here. I'm not going to rewrite it. Why would I rewrite it? It's right here. I'm just going to go ahead and just click on that cell. You could rewrite it if you want to, but I'm trying to teach you a little bit about Excel and efficiency here. All right, so there's your standard deviation. You can see it's calculated right over here. It's the same thing. All you have to do is click in a cell, and again, all I did was click in a cell, and then just go ahead and click on that, and it'll give you that answer. And the cumulative, again, is always 1. So less than 16.6 for the 33 samples is that, 0.3509, I guess. So for 17.1, again, do the same thing. More functions, statistical, norm.dist, and again, the x is 17.1, mean 17, standard deviation, again, I'm going to go grab that one because that's the one we're using, cumulative, always 1. And again, I could go in my calculator and do this one minus this one, but I'm gonna make it easy. I'm gonna hit equals. You always have to hit equals when you're doing that thing. When you're doing a calculation, equals this number, cell, whatever's in that cell, minus number in that cell. There's gonna be your answer, 0.1873. You're on 0.1872. Okay. Okay, good. It took 0.1873